All right, guys, so looking at 9.3 here, and 9.3, we are uh, solving quadratic equations using square roots, so using a different method than factoring. So it's actually a little bit easier than factoring, but we can only use it in a specific uh, case. Okay, we can only use it in a specific case, and it says it right here. Right, so if you're looking at the book, which we have right in front of us, it kind of explains it right here. Okay, but we are looking specifically at when we have ax squared plus c equals 0. So we don't have that bx term. We don't have that extra x in the middle. We just have an x squared. That allows us to solve by square roots. So this is the method you're going to use anytime you see ax squared plus c equals 0. So anytime you don't have that bx term, that term in the middle, this is how we're going to solve, because it is going to be um, easier than any other method that we have. It's probably the easiest method that we have to solve quadratic equations, but again, it only works in this case. So remember or I guess maybe not remember, but what we need to do here is to get x squared by itself. And once you have an x squared by itself, right, if you have x squared is equal to something, right, let's say we have x squared by itself, then you can take the square root of both sides. Remember, the square root and the squared sign cancel each other out. That's how we get rid of that squared to get to just x. So if we did that, we would get here. Now, the square root of 25, right? The square root of 25 we say is 5, but remember, it could also be a negative. And we talked about that before. It could also be a negative 5, because negative 5 times negative 5 also gives us that positive 25. So when we write our answers, it's going to be a positive or negative in there. And you see that down below, right? Example 1, you see that answer there. So that's a plus or minus or positive, negative. Typically we say it's a plus or minus 5 or a plus or minus 3. That gives us two solutions. Remember, a lot of times, most of the time, our quadratic equations are going to have two solutions. It's going to cross the x-axis at two different points. So that's why we need the positive and the negative there. So what we're going to do is we're going to kind of walk through a little bit. I'm going to show you how to solve a couple of these things, and then we'll be done, right? But a couple of things that we need to look at, and I'm going to use the whiteboard here just because it's cleaner. It's easier for me to use. You can look through the book if you want to. You can do this stuff on your own. I'm going to go through some examples, and I am going to ask you to try some on your own. So have some paper and pencil with you as well. Hopefully you got your notes out. But that first one, let's look at that first one. I know you saw the answer. We mentioned the answer, but let's just look at it for a second here. We have 3x squared minus 27 equals 0. And remember, the whole idea here, the whole point is to get x squared by itself. We have to get x squared by itself. So everything else needs to go on the other side. So we add the 27 over. Okay, we get here. We got to divide by 3. Make sure that you're solving correctly. I mean, we've done this since chapter 1 now, right? But get rid of that addition or subtraction first, then we can worry about the multiplication. So we do that. We get x squared is equal to 9, and then we take the square root of both sides. Remember, that cancels out. We are left with a positive or a negative 3, and you have to get that plus or minus. That is very important. If you only say that the square root of 9 is a positive 3, you're only getting half of the answer. It's a positive or a negative 3. You got to have that symbol there. Okay? All right. Let's move on to the next one. The next one would be x squared minus 10 is equal to negative 10. So if we try this one, again, we want x squared by itself. So we add 10 to both sides. That gives us x squared is equal to 0. Well, take the square root of both sides. Again, that cancels. The square root of 0 is just 0. And contrary to what some of you like to think, there is no such thing as a negative 0. So we are just looking at one solution. So our one solution there is x is equal to 0. With this method, the only time that you're going to end up with one answer is if the answer is 0. The only time you're going to end up with that one solution is when you have x squared is equal to 0 in your equation. Okay, so we looked at the first example we did had two answers, right? A positive, -3. Next example we did had one solution where x is equal to 0. And then we are going to look at one more here that gives us -5x squared plus 11 equals 16. Let's try this one. If we do this one, we got to get rid of that 11 first, so we subtract 11 from both sides. That gives me -5x squared is equal to 5. We got to divide, we got to get rid of that -5, so we divide by a -5. But what happens here is we end up with x squared is equal to -1. Well, if I take the square root of both sides, I can't take the square root of a negative. You can't do it. You can't do that. Can't do that, right? So you can't take the square root of a negative, which means this is our no solution case. This is our no solution, which remember was when if you graphed it, it wouldn't cross the x-axis, something like that. So you can't do that, right? It's like a big frowny face here. You can't do it. But that is no solution. Anytime you have x squared equals a negative, x squared equals a negative means it's no solution. You can stop right there and just say no solution with it. Okay? Let's look at the book again here. And I zoom right in on it. It tells you right here, right? When D is positive, then there are two real solutions, the plus and minus, right? When D is 0, then it has one solution, and it's going to be x is 0. When D is negative, then there are no solutions. So that's an important core concept. I would have that in your notes, right? I would make sure that you understand that concept moving forward. That's going to make things a lot easier for you. All right, so what we're going to do now is I'm going to show you these. I'm going to put these 6 up there, okay? What I'd like you to do is I'd like you to pause and try out these. Actually, you know what? We didn't do example 2. Let's do example 2 first. Huh? That would make sense. Otherwise, you wouldn't be able to do it. Let's get a whiteboard up here. So this one, the next one, sorry about that. A little sidetracked. This example would be x minus 1 squared is equal to 25. So now this looks different, right? We don't have an x squared. We've got something in parentheses squared. That's fine, but you can't take that -1 out of the parentheses. That -1 is part of the parentheses. It's got to stay in there. So what we need to do is get that parentheses by itself. Okay, you need to get the parentheses squared. Whatever is squared, you need to get that by itself. And in this case, it's the parentheses. So get that by itself. So at this point right now, take the square root of both sides. Take the square root of both sides, right? Because what that's going to do is that's going to cancel out this squared. That's going to give me x minus 1 on this side, because it's just whatever was under that square root. But on the other side, the square root of 25, you might be tempted just to put 5. But remember, that's a positive or a -5. Anytime you take the square root in an equation here, you have to do the positive and negative. So what that does for us is that separates this into 2 different equations. That gives us x minus 1 is equal to 5, and x minus 1 is equal to -5. And then we have to solve both of those. So this is going to give us x is 4. This is going to give us x is a -4. Right? So, oh, sorry, this is not 4. This is 6, because we add that one over. There you go. So x is 6, x is -4. Those are my 2 answers. So it's not the answer here. A lot of times students will just say the answer is positive -5. You got to keep going because we still have that x minus 1 here. Right? So split it up into 2 equations and do it that way. Let's try one more of those before we move on and you try some on your own. Let's go x plus 7 squared is equal to, let's say, 9. Let's do this. Okay, similar to one that's in the book, it is slightly different though. So the parentheses squared is by itself, so take the square root of both sides. That's going to cancel. I have x plus 7 here. I have a positive and negative 3 over there. So I got to split that up. That's x plus 7 is equal to 3. X plus 7 is equal to negative 3. Subtract the 7 over here and we get negative 4. Subtract the 7 over here, we get negative 10. Those would be my two answers there. All right, so now I think we've got the idea behind it. Let's do this. Now let's look at those equations. Pause it, try them, okay, and come back and we'll talk about what our answers are going to be. All right, so let's talk about those answers, okay? So let's get that whiteboard back up. We can talk about it. That first one, negative 3x squared equals negative 75. You got to get the x squared by itself, so divide by negative 3. That's x squared is equal to 25, a positive 25. We take the square root of both sides, and we get plus or minus 5 for that, okay? The next one we do is x squared plus 12 equals 10. Subtract the 12. That gets us x squared equals negative 2. That should pop out as a red flag there. You can't have x squared is equal to negative. This is no solution here. Okay. The third one that we have 4x squared minus 15 is equal to negative 15. Add the 15 over. That's going to give you 4x squared is equal to 0. Divide by 4. That gives us x squared is equal to 0, which means after I take the square root, x is 0. There you go. All right, moving on to the ones with the parentheses. X plus 7 squared equals 0. Well, we take the square root here of both sides. That cancels out. I'm left with x plus 7, but that's just 0. Remember, it's not positive or negative. It's just 0. So here I only have one solution. I have that x is equal to negative 7. Let's try the next one. This one's a little trickier. So let's take our time. Let's talk about it. 4 parentheses. X minus 3 squared is equal to 9. We got to get rid of that 4 first. We got to get the parentheses to, by themselves before we can take the square root. So we divide by 4. Now you're going to be tempted to type that into a calculator. Don't. Just leave it as 9 over 4. And hopefully you guys have been doing enough work with perfect squares that you can recognize that 9 and 4 are both perfect squares right away. So now if we take the square root of both sides, yes, this side cancels, which leaves me with x minus 3. But on the right side, I can do the square root on top and square root on bottom. Right? The square root on top is 3. The square root on bottom is 2. So that's going to give me a positive and negative 3 halves. Which means, again, I got to split it up. X minus 3 is equal to a positive 3 halves, or 1.5. And the other side is going to be x minus 3 is equal to a negative 3 halves, or a negative 1.5. What that does for us, we add 3 to both sides. We're going to end up with 4.5 over here. And if we add 3 over here, we're going to end up with 1.5 over here. So we've got those two solutions. That's a tricky one. Okay, so take your time, look through it, make sure you understand what we did. The last one here, I got 2x plus 1 squared equals 36. Take the square root of both sides. That gives me 2x plus 1 is equal to a positive negative 6. Split that up. 2x plus 1 is 6. 2x plus 1 is negative 6. And then you just got to solve those equations. Subtract the 1 from both sides, divide by 2. That's going to give me over here, that's going to give me a 5 halves. And over here, that's going to give me a negative 7 halves. So those are my two solutions for that one. Hopefully you can get from where I left off, here and here, you can get those answers. That's just a basic two-step equation there. Okay, so that is the majority of what we're looking at. I got one last thing to talk to you about, one last thing to show you, is example 3 here. And example 3 is just showing that you might not get whole numbers, or you might not get 0.5s. You might get something weird, and you might have to actually round, and it's going to want you to round to the nearest hundredth. So you look at this example, right? We'll just look at this example right here. 4x squared minus 13 equals 15. Add the 13 over, we get 4 x squared is equal to 28, divide by 4, and we get here x squared is equal to 7. So now x squared is by itself, so we can take the square root of both sides. Take the square root of both sides. But the square root of 7 7 is not a perfect square. So we actually have to use that calculator. Type in square root of 7. Don't forget about the positive or negative though. And just round it correctly, we get a positive negative 2.65. Okay, that's what we're looking at here in 9.3. The book goes on to talk about example 4 and 5. Don't worry about 4 and 5. If you want to look through it, you can. I don't think there's anything on the homework with that. Most of it's just going to be examples 1, 2, and 3 here. So there you go. That's section 9.3. Hopefully that helps.